Robot Talk is the podcast that sits down with robot enthusiasts from around the world and asks them the questions you always wanted answered. Like, can I program the robot? And how does that thing work? Hello everyone, welcome to Robot Talk. I'm your host, Claire Asher, and this week I'm learning more about robot software and how easier programming can open up the world of robotics to non-specialists. But first, I'd like to remind you to rate this episode and leave a review if that's something you can do on the platform you're listening on. And don't forget to share the podcast on social media or tell your friends about it. It really helps the podcast reach more listeners. So, with all that said, it's time for me to introduce this week's guest. I recently had a great chat with Nick Thompson from Bo about software that makes robots easier to program. Today, I'm chatting to Nick Thompson, CEO of Bo, a robotics software company that aims to make robot programming seamless across any hardware. Hi Nick, great to have you on the podcast.
Hi there.
So for listeners who might not be familiar with Bo, can you tell us a little bit about the company and its robot software platform?
Sure. Now, there's a problem in the robotics industry in that there's lots of different manufacturers, lots of different models. And you know, for someone coming into robotics and trying to work with these robots, it's a bit of a minefield. Where do people start? You know, do they buy a robot? Do they, use something like ROS or simulation? It's very difficult. It's a very high barrier to entry. And of course, there's new robots coming out all the time. So we've built a platform that abstracts that complexity away. It enables developers to build applications in a sort of unified, agnostic way. And that will work across simulation and across the real-world hardware. So it's effectively an SDK for robots and for software developers to get going with robotics and make proper, robust applications.
What's an SDK?
Software development kit.
Okay. Okay. And so it kind of acts as a translator between the programmer and the robot itself.
Yeah, that's right. It's a bit like a middleware. So it's translating the robot-specific commands that will control the robot, but also to extract the data. So we have a common data description of the robot, and in such a way that developers can build applications without having to think about necessarily the hardware, and in some cases even the form factor. So when I say form factor, I mean, is it a bipedal humanoid? Is it a quadrupedal dog? Is it a wheeled rover? Even a drone? All of these different form factors are like completely different. But with Bo, it's really making that sort of quite consistent across the board.
Yeah, that sounds incredibly complicated to actually do, because the commands that would go into a quadruped would be quite different from those that would go into a wheeled robot.
For sure. But I think, you know, as a developer, you're trying to get a job done. Perhaps you're moving a robot around a warehouse or maybe doing some sort of last mile delivery. You just want to make it go forward, don't you? You want to be able to look at the camera, the LiDAR, the other sensors, perhaps the distance sensors, and make a decision. So why should that be horribly complicated? And without Bo, honestly speaking, it's a massively complicated problem to solve. And you're very much tying yourself to a very specific robot and sort of sinking all your time and energy into that robot. What happens if that robot changes or needs to change or becomes discontinued? You know, that's the world we live in at the moment. So that's what Bo's all about.
And so I think you might have already answered this question, but we had an audience question from Squads on Mastodon who said, what is one of the biggest challenges in robot programming today?
I think I've said it already. It's just hard. It's super hard. You know, we've got ROS. I'm sure we'll come on to ROS later. You've got ROS 2. They're the de facto solutions. But nobody who's just working on everyday software development, maybe mobile apps development, web applications, desktop applications, to get into ROS is like tear it all up and start again. So we're trying to make something that enables people, lowers the barrier to entry, makes it much more accessible to get into robotics. So yeah, the challenge is today, it's just too hard.
Yeah. So you mentioned ROS. Some listeners might be aware of ROS, the Robotic Operating System, which is an open source platform for robot software development. But we had an audience question from Vincent on Mastodon, who wanted to know what the difference is between Bo's software platform and ROS, and how the two can work together.
Yeah, so there is a big difference. We're not trying to replace ROS. That would be silly. ROS has got absolutely a huge community, and a lot of robots that you'll buy off the shelf will be ROS enabled or ROS 2 enabled. Now ROS is starting to become obsolete. The original ROS, although robots built, right? They're configured with ROS and they're going to stay using ROS. So ROS isn't going away either. So what we're doing there is we're complementing that platform. Yeah. Now, if a robot is ROS enabled, we can build a connector between the ROS enabled robot and our software platform. And actually that helps us. That makes the job easier for us. It makes the job easier for people building their own Bo drivers, because there's a sort of driver development kit side of Bo as well to do the sort of lower level link up between specific robot and Bo where there isn't already a driver. ROS helps in that case. Sometimes robots aren't ROS enabled at all. They have a proprietary SDK. And in some cases, to program that robot, you have to be issuing low-level sockets, UDP, TCP commands, right? So again, that's another minefield of complexity that we're abstracting away.
Mm-hmm. Because, if I understand right, ROS has really been developed for the robotics community, for people who live and breathe robots.
Yeah. Well, exactly. And to be honest, our motto is, with Bo, any software developer can be a roboticist. And that's because, we're not necessarily aiming this at the hardcore roboticist. Yeah. Although we think people with an open mind would embrace it because they're able to get the job done faster. We're solving a load of common problems in robotics. For example, the comms side of it. If you want to talk to a robot from a controller, and that robot's not necessarily on the same network, it's across different networks, different subnets, or across the cloud. That's very hard to do. Again, you're going to have to create lots of bridges and low-level communication code to do that. And we've done that bit already. We've done some very clever low-latency comms between robot and controller. So you don't have to do that. We figured out the whole inverse kinematics algorithm. We've got a very unique way of doing that. So again, these are problems that people are continuously trying to solve. Or they're using perhaps the robot's built-in IK, which is fine, but then if you want to change to a different robot, you're having to start again there, or maybe you can't do what you're doing before. So we're trying to make this a very simple case of making reusable applications for robots, and then there's a decoupling of the hardware and the software, so the robots are interchangeable.
Yeah, I guess as well, if you're a company where maybe you want to have a fleet of different kinds of robots, maybe you've got some wheeled mobile robots and you've got a robot dog, you could use essentially the same commands to control all of them.
Oh, absolutely. In fact, we've proven that. We've created a showcase application that we call Mission Control. And the idea of that is that as a user, not necessarily a developer, but a user of a robot, you want to make it go around a route like a patrol or an inspection, to come back to the beginning again. And then you want to be able to replay that autonomously so it can go off and do its thing. Now, a security patrol or an inspection could be carried out by all manner of different form factors. The robot dog, the wheeled rover, whether that's on small wheels or sort of tank-like wheels. There's all sorts of different ways and form factors of robot. Even humanoids are going to be doing this sort of thing. But humanoids really aren't commercially available yet. With some exceptions, I would say they're not really ready for the real world. But they will be, right? This is coming. So why not create the applications you need now using certain robots that do the job, knowing that even better robots are coming down the line, and it's the same code, it's the same applications that are driving those robots. Because at the end of the day, the clever bit is all about the environmental interpretation, right? Our customers should be building applications that can do the AI on the vision, on the sensor information, the LiDAR data, if that's what they decided to use, and be able to do sort of cognitive work, understanding people, understanding what it can see, and taking action accordingly. The bit about talking to the specific robot hardware shouldn't be a complete nightmare every time, where people are reinventing the wheel and doing that comms stuff and trying to figure out the intricacies of this particular ROS style of work, which topics have been used and so on. So we're trying to simplify that whole process for people so they can just get to making a working product.
Yeah, fantastic. So can you tell me about one of the most interesting or innovative use cases of Beau's software that you've seen so far?
Yeah, I would say that's probably where we're working with the offshore renewables energy catapult. There's a project we're working on there called Osiris, or I say they're working on it. And it's a major initiative, and it's funded by Innovate UK, and it's to transform offshore wind maintenance. So it's a joint project with Acua Ocean and the ORE catapult, and it's basically building a fully autonomous inspection system using aerial drones, underwater robots, and a sort of ship, which is a sort of unmanned surface vessel. It's really cool. It's quite a staggeringly beautiful machine that has been created. So I think what's super powerful is that Beau's acting as that unifying software layer. And you've got these different robots, the air, the land, the sea, or the subsea, working together as one coordinated system. So ultimately, the project is about replacing the sort of expensive, risk-prone manual offshore work with a scalable, zero-emission robot solution. And of course, I think where we see this being successful, it's not just going to benefit the offshore wind world. It's really rewriting how we approach autonomy in the entire marine sector.
Yeah, fantastic. I mean, obviously, offshore wind is expanding rapidly, and I hope will continue to do so. So that kind of thing is really useful and important.
Absolutely.
So what's next for Beau? What projects or developments are you really excited about for the next few years?
Well, I think what's next is scale. We've built I wouldn't say the first iteration of our technology. It's been through many, but it's commercially ready. So we've built the SDK that makes programming robots as straightforward as writing a mobile app or a web app. But now it's about expanding the ecosystem. And I'm really excited actually about us getting the App Store marketplace built. So that's going to be a platform where developers can share and monetize robotic capabilities and skills, reusable skills across robots. And it's a pretty cool concept. It's kind of like the Matrix, people being able to take their robot and download a skill to it. That's the future we see. These robots should be commoditized and should be general purpose. So that's the world we're going towards. And I think, for us, it's combined with OEM partnerships, more OEM partnerships and deeper integrations. And that's really going to turn Beau from a powerful tool into the connective tissue, I would say, of the robotics industry.
Yeah, that's really exciting.
We're thinking about taking this to market. So we're obviously very keen for developers, people in the robotics industry to try the platform. They can go to usebeau.com. It's very easy to get started. It's very sort of low impact. You download the SDK onto your Windows box or your Linux machine and install the program. It only takes a few minutes. And there's a whole bunch of really cool tutorials and documentation to get you started. But feedback is everything. So keen to hear people's feedback at this point. And then over time, we'll be building that community.
Absolutely, yeah. Brilliant. So I'm not a software developer, as you may have guessed. If I wanted to use Beau, what kind of learning curve would there be for someone, a complete newbie?
Yeah, there's obviously a learning curve with anything you do you haven't done before.
Yeah.
Putting it into perspective, I think, is where Beau, makes it, let's say, something like 100 times easier to get into robots. So I'm not saying that you're going to be able to immediately do things that are really spectacular with robots within minutes. But you really can download the simulator and install it within a matter of minutes. You can then clone a GitHub repository of tutorials, and you can then run those using either your preferred language of C# for .NET, C# for Unity, Python, and C++. So we're covering all those languages and more to come. We're also looking to build a Mac version as well soon, but it's not out yet. So we don't want to promise that that's there when it's not, but that is coming. And then with those tutorials, you can just hit run, in your code IDE that you're using, and that will work. So that will work on the simulator that you've got running in your computer, and you'll see that moving. Now, if you have a robot, then you can apply that application to the real world robot. Depends which robot you've got. We aren't supporting every robot out there at the moment. We've supported a lot, but there's more to come, and obviously we can do them on request as well. So we're looking for people's feedback. They might say, look, I've got this particular robot. I love Bo. I love how easy it is to build my application. Can you support this robot? We'll do that on demand. But in the meantime, we're sort of adding to our portfolio in the background as we go.
Brilliant. I know there are a few makers and hobby roboticists out there who listen to the podcast, so it would be great if they could give it a go as well.
Please.
Nick, it's been great talking to you today. I've been speaking to Nick Thompson from Bo. Thank you.
Thanks.
Thanks for listening. If you enjoy Robot Talk, please share the podcast, subscribe, and leave a review. It really helps boost the podcast, so thanks in advance. And don't forget to join the Robot Talk community on Patreon if you'd like to support the podcast and get access to some awesome perks, including behind-the-scenes updates and monthly bonus episodes. Visit patreon.com/Claire Asher to find out more. Next week, I'm chatting to Amy Leveres from the Robotics, Automation and Dance Lab about robots in the performing arts. Until then, I've been Claire Asher, and this has been Robot Talk. Robot Talk is brought to you by the Hamlin Centre, Imperial College London.